Howdy everybody, and welcome to today's lesson about point-slope form. Point-slope form is another way to write the equation of a line. And by the end of this lesson, you'll be able to both write equations in point-slope form and graph equations that are in point-slope form. So let's go ahead and get started. This is the general form for point-slope form. x1 and y1 represent a point, shown here. M, again, represents slope. X and y are both variables. Whenever you are writing the equation in point-slope form, you need both a point and a slope. So let's go ahead and get started, and we'll show you how to put lines in point-slope form. So in example number 1, I've got the point 8, -4, and it has a slope of 2/3. So what's the equation in point-slope form? Okay, remember your general form is y minus the y-coordinate equals the slope times x minus the x-coordinate. So let's go ahead and plug in the information that I'm given. I've got y minus the y-coordinate, which is -4, equals the slope, which is 2/3, times x minus the x-coordinate of my point, and that's 8. I need to do a little bit of simplifying on the left side of my equation. When I subtract a negative, that turns to addition. So my final answer is y plus 4 equals 2/3 x minus 8. And there you have it. That's a line written in point-slope form. So you'll notice I essentially take the opposite of whatever the coordinate is. This coordinate was -4, so when I plugged it in, it became y plus 4. Keep that in mind because things can go a little bit quicker if you use that. So in the next example, I've got a point, -3,6, and I've got a slope, -5. When I write the equation of that line, it's going to be y minus the y-coordinate, which is 6, equals the slope, -5, times x minus the x-coordinate, which is -3, so that's x plus 3. And there's your final answer of your line written in point-slope form. So we've taken a point and a slope and put it into that form. Let's try some graphing. Okay, looking at the equation of this line, I can tell what a point is. I can also tell what the slope is, and I'll use those two pieces of information to graph the line. So in this first equation, the point is the point 4, -7, and remember I have to take the opposite of the sign here, so it's the point 4, -7, and the slope is -4/5. So I move over here to my graph. I'm going to put a point at 4, -7, 1, 2, 3, 4, and then down -7, it's 5, 6, 7. And from there, I'm going to move my slope. So my slope is -4, 5. If I go down 4, 1, 2, 3, I run out of room. So instead of going down, I'm going to go up 1, 2, 3, 4, and then I have to go to the left. 1, 2, 3, 4, 5. Right? Then I can connect those 2 points with a straight line. Boom. Let's try it again. I need 2 pieces of information, a point and a slope. And since this is point-slope form, it shouldn't be too bad to find those 2 things. The point is the point 2, 1, and the slope is 2/3. So from those 2 pieces of information, I can go ahead and move over to my graph, and we'll get this graph done. So over 2, up 1 is the point, and then from there is my slope. I move my slope up 2, 1, 2, and then to the right 3, 1, 2, 3. I've got 2 points, and that's enough to make a line, so I'm going to go ahead and draw my nice line through there. Shoop. Make sure you are using a straight edge when you do these graphs so we can have nice, neat lines. All right, example number 3. In example number 3, we want to write an equation for the line that's graphed below, and we're going to write it in both point slope and this should be slope intercept form. Apologize for that. That's slope intercept form. So we're going to write it in both forms. Okay? We're going to start off in point slope form. So in order to write something in point slope form, I need a point and I need a slope. Well, up here I've found a point. It's 1, 4, and it doesn't matter what point on that line, any point on the line will do. So I'm going to use the point 1, 4, and then to find the slope, I need to use my slope formula. So y2 minus y1 divided by x2 minus x1, and we get that my slope here is 7 over 3. So I'll go ahead and write this in point slope form. Y minus 4 equals the slope times x minus my x coordinate, which is 1. All right, now to write it in slope intercept form, which you'll remember is y equals mx plus b, you'll notice that y is all by itself. There's also no parentheses. So to convert from point slope form to slope intercept form, I need to distribute my 7/3 and then move 4 to the other side. So here it goes. Y minus 4 equals 7/3 x minus 7/3. To get y all by itself, I need to add 4 to both sides. So y equals 7/3 x, and this is where the fun happens. I have to do a little side work to add these fractions. I've got negative 7/3 plus 4. In order to add fractions, I need to have a common denominator. So negative 7/3 plus 12/3 equals 5/3. So my final answer is y equals 7/3 x plus 5/3. There you have it, folks. There is the equation of line in point slope form and in slope intercept form. All right, let's turn to the back. On the back, we're going to do one application question and then it's your turn. So this asks me to write an equation in slope intercept form for the balloon's altitude at any time. And then what do the slope and the y-intercept represent? So first thing I want to do is I'm going to find a point, and I can do that by looking at the time versus the altitude. So one point would be 0.10 and 640. And then I have to find the slope. To do that, I'm going to do y2 minus y1. That's 590 minus 640 divided by 30 minus 10. So 590 minus 640 is going to be negative 50. And 30 minus 10 is 20. So my slope is negative 5/2. That makes sense because this hot air balloon is descending. Okay, so to write it in point slope form first, and then I'll convert it. Point slope form is y minus 640 equals negative 5/2 times x minus 10. In order to convert it, I need to distribute the 5/2. So y minus 640 equals negative 5/2 x plus 25. I'll then add 640 to both sides. So y equals negative 5/2 x plus 665. In this question, the y-intercept is the initial altitude and the slope is how fast that hot air balloon is going down. So we'll say it's the rate of descent. All right, now it's your turn. Try the self-quiz and then check your answers. All right, on the self-quiz, you're writing an equation in point-slope form. You're given a point and a slope, so your equation should be y minus 6 equals 1/5 x plus 1. That's your final answer there. In the second question, you need to graph. To graph it, you need to know a point, and that point is -1, 1. And your slope is going to be 2. So you're going to go over to your graph, -1, 1, and then you're moving your slope up to boop, boop, over 1. And then you'll connect those points with a nice straight line. All right, last question number 3. What is the equation in point-slope form below? So you need to have a point, and you also need to have a slope. The point I'll choose, let's go with 3, -2. And to find the slope, we need to use our slope formula. So I'm going to do 0 minus -2 all over -3 minus 3. Two negatives become positives. That's 2 divided by -6, which is -1/3. So your final answer here should be y plus 2 equals -1/3 x minus 3. There you have it. Hope you learned a bunch today. Be sure to go back and check your work if you missed anything on the self-quiz. And that's all for now.